We often look to the sky for the future of technology, imagining our digital world floating wirelessly in space. Yet, 99% of all transcontinental internet traffic travels not through satellites, but through silent, dark cables resting on the ocean floor. Every email, video stream, and financial transaction we send across oceans depends on this fragile underwater web. If these deep-sea lifelines were suddenly severed, modern society would grind to an instant halt, exposing the physical vulnerability of our virtual lives. At their core, these submarine conduits are surprisingly simple, consisting of ultra-pure glass threads no thicker than human hair. Through these tiny tubes, intense pulses of laser light carry vast oceans of digital data across thousands of miles of deep abyss. This incredible network traces its roots back to 1858, when the very first transatlantic telegraph cable was laid. This pioneering project allowed Queen Victoria to send a message to President James Buchanan, reducing communication time from weeks to minutes. Today, the scale of this underwater infrastructure is staggering, spanning nearly 500 active cable systems worldwide. These vital digital highways stretch over 1.4 million kilometers, enough to wrap around the entire circumference of the Earth 35 times. To transmit data, lasers at coastal stations fire beams of light billions of times per second. This light travels down the glass cores through total internal reflection, bouncing continuously off the walls without escaping, preserving the critical data across vast distances. While the glass fibers are incredibly thin, the outer protective casing is thick and complex. Layers of petroleum jelly, copper, steel wiring, and heavy plastic protect the delicate glass cores from intense deep-sea pressures, ocean currents, and curious marine life. Deploying these cables requires massive, specialized ships carrying thousands of tons of spooled line. Near coastlines, these vessels drag heavy sea plows along the seabed, carving deep trenches to bury and protect the cables from dragging ship anchors and fishing nets. As light pulses travel through thousands of miles of glass, the signal naturally degrades. To solve this, engineers install massive, cylindrical signal boosters called repeaters every 80 kilometers, powered by thousands of volts running directly through the cable itself. Deep in the vast ocean plains, where human activity is virtually non-existent, cables actually lose their heavy armor. In these silent depths, thousands of meters down, the cable is stripped to the diameter of a simple household garden hose. This massive underwater network is highly vulnerable, and accidental breaks occur about 200 times every year. In 2022, a violent volcanic eruption severed Tonga's single submarine cable, plunging the entire Pacific nation into weeks of near-total digital isolation. Beyond natural disasters, these cables have become critical chess pieces in global geopolitics. Superpowers closely monitor landing stations, where cables touch the shore, as these locations represent highly strategic nodes for potential espionage, data interception, and physical security. When a cable breaks, specialized repair ships rush to the coordinate using advanced global positioning systems. These crews deploy robotic submersibles to locate the damaged ends, retrieve them to the surface, and meticulously splice the glass fibers back together. Today, tech giants like Google and Meta are bypassing traditional telecom companies to fund their own private cables. Furthermore, scientists are now testing ways to use these underwater fibers as giant acoustic sensors to detect earthquakes and devastating tsunamis. The global internet remains anchored to the dark, silent depths of our oceans, a testament to human engineering. As our data demands grow, this fragile, hidden network will continue to expand, quietly holding our interconnected world together.